So a very good morning to all present here. Honorable guests and dear authors, I, Sumanj Barwal, moderator of this session, welcomes you all to the technical session 3A. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the 8th International Conference on ICT for Sustainable Development, Goa, India. This 8th edition of conference is being organized in a hybrid mode. The physical event was held in Goa on the 3rd of August, and the virtual event is being held through Zoom today and tomorrow, that is 3rd and 4th of August. I hope that you all will enjoy the knowledgeable and interactive session throughout the day. So before proceeding, let me brief you about how today's session goes on. So we have 10 presentations in total, and each presenter would be getting 8 minutes to present their presentation and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder so that you can conclude your presentation as soon as possible. All the authors are requested to please adhere to the timings because we are short on time. There is another request to all the participants that you all please stay connected with us till the closing remarks. So if you have any query, then you can write it to me in the chat box. So just before we get started, let me introduce you all to the chair for this session. So for today's session, we have with us Dr. Paras Kothari. Dr. Paras Kothari is presently working as a professor in the domain of computer application and pursuing research in information system implementation in various segments of business and medical sciences. Recently, Sir was awarded academic recognition of honorary doctorate of engineering for his contribution and study in expert system and MIS in cognitive neuroscience. The 22 plus year strong academic career with versatile research papers in national and international journals lead Dr. Kothari towards academic research. Presently, his 3 research theses are submitted and 3 are in progress with esteemed private university of Rajasthan. It is our great pleasure to have you here with us, sir. So before we start with the session, would you like to say something?
Thank you, Shamans. But I think your voice is very low.
So voice is low.
Now it's better.
Sorry for that, sir. Sorry for the inconvenience. Would you like to say something, sir, or shall we start?
I think we're going to start one by one. As you said that there are 10 papers. So
yes, sir.
We are having the sequence. So I think according to sequence, we may start. Right?
Okay, sure, sir. So let's move on to the first paper. So the first author is Tanuja R. Patil, and her paper title is A Byte Transformation Technique for Lossy Image Compression. Tanuja ma'am, are you listening to me?
Yes, sir. Yes, sir.
Ma'am, you may please present.
Yeah. So I will share the screen.
Yes, ma'am, sure.
Yes, sir. So good morning, everyone. So today, myself, Tanuja Patil, I am going to present my research work on a byte transformation approach for lossy image compression, and my paper ID being 50. And my co-author is Dr. Vishwanath P. Badigar. He is working as professor in School of Computer Science, Kelly Technological University, Hubli. And contents being introduction, then literature review, proposed methodology, compression phase, decompression phase, results and conclusion, and references. So why do we need image compression? So actually, this is not the question to be asked. That is, in modern days, we know that images constitute a major part of the data being stored and communicated. They consume a lot of space because of their larger file size. Hence, it is required to reduce the size of an image file for its efficient storage and transmission. So there are 2 types of compression possible. One is lossless and another is lossy compression. So here we know that lossless image compression is required in the applications like medical images, satellite imagery, etc., where perfect reconstruction is required and compression ratio becomes lesser. And the compression techniques used here are like Hoffman coding, arithmetic coding, LZW coding, run length coding, etc. And recently, predictive-based techniques are being used. And we know that lossy image compression is okay in some of the applications like GIS, multimedia data, which consists of audio, video, and images. So compression ratio here becomes higher with slight loss in information. And the compression techniques used here are various transform coding like discrete cosine transform, wavelet transform, etc. So So in this regard, we did a literature survey, and this is the various papers we have surveyed. And as per Sinisa et al., we came to know that at lower values of bit rate, the adverse effects arising from the compression methodology appear in JPEG. So JPEG is used as the standard today also. But in this, we found that contours of blocks become visible at low PSNR values. A blurring effect appears. That's why it is required to improve the quality of reconstructed images at low PSNR values. So this we have taken as the problem definition, and we have started with finding new methodologies for the compression, and we came up with the byte transformation approach for lossy image compression. So what is the proposed methodology that I'm going to discuss here? So coming to the compression phase. So the image compression algorithm goes like this. So in step 1, we'll read the grayscale image and divide into blocks of 4 pixels. For example, I have taken the sample of Lina image, which is the standard IEEE image used for testing. And here this is the sample, and we know that the image is stored as the pixel intensity values. So 162, 164, 161, 163, these are the pixel intensity values. So let us call this as the first block of 4 pixels. That is P1, we'll call 162 as P1, 164 as Q1, 161 as R1, and 163 as S1. And we'll consider the next block also, that is P2, Q2, R2, S2. And this is the third block consisting of P3, Q3, R3, and S3. So we'll convert 4 pixel data into 3 bytes. So the first block, P1, Q1, R1, S1, it is a 4 pixel data. So that will convert into 3 bytes in this way. So first we'll form the G1 group of 2 most significant bits, which will form a byte 1. And we'll form another group of bits, which is consisting of 5th, 4th, 3rd location bits, and it will form a byte 2. And we'll form another group of bits at 2 and 0 locations, and we'll form the byte 3. So this is how 3 bytes are formed out of 4 bytes. So 1 byte is reduced. This is how we can achieve the compression. So in the second step, we'll write the decimal value of the pixel intensity in 8-bit binary form. So write these 4 pixels into binary form. That is, we have considered P1 as 162, and its binary value is 10100010, and Q1 is 164. Its binary value is this, and similarly for R1 and S1. So all the pixels we'll write in the binary form. So we'll see how the byte 1 is formed. Formation of byte 1 using G1 group of bits. So now consider 2 most significant bits of these pixels. So P1 is 10. How? We'll see here. P1 is 162, which is 1010 in this way. So we'll consider the bits located at 6th and 7th positions. So this is nothing but 10. Similarly, if we see Q1, it is also 10. If we see R1, it is also 10. If we see S1, it is also 10. So now we'll concatenate the 2 bits of all 4 pixels to form B1 is equal to 1010. This byte is to be stored in a file B1. So this is how we'll form the byte 1 out of only the 6th and 7th bits. So where lot of correlation exists. And now we'll see how the byte 2 is formed. So byte 2 is generated by logical OR of bit positions of group 2 bits. The bit positions of the 4 pixels are determined as follows. That is, for example, we'll consider pixel P1. So here, this is the pixel P1. So group 2 bits. So that is nothing but bits lying at 5th, 4th, and 3rd bit position. So this is the 3rd, 4th, and 5th bit position. So they are nothing but 100. So it is nothing but 4 in octal. So 1 is marked at bit position 4, and 0 is entered in all other bit positions. Similarly, bit positions for other pixels are also determined and found to be 4 in all these cases. So here also we can find high correlation. That is 100 here, 100 here, 100, 100. So considering all these, this is the bit position table. So these are the bit positions: 0th position, 1, 2, 3, 4th positions. And these are the pixels P1 having 3rd, 4th, and 5th bit position. So bit position of third, fourth, and fifth is nothing but 4. So 1 is entered in, for all these pixels, it is 4. So we have entered 1 in the bit position 4, and we have entered 0 in all other. So next, what we'll do is we'll.
Sorry to interrupt, Tanuja ma'am. You've just got 1 minute, ma'am. Please.
Yes, yes. So byte 2 is formed by logical OR of all the above formed bytes. So this is the logical OR. After ORing all these logically, we'll get this byte. So this is called as byte 2. And the formation of byte 3. So byte 3 is generated by logical OR of bit positions of group 3 bits. So bit positions of the 4 pixels are determined as follows. Again, for pixel P1, if we see, group 3 bits are the bits located at 0, 1, and 2 positions. So they are nothing but this one, that is 0, 1, 0. For Q1, it is 1, 0, 0. So here we can see that it is nothing but 2 in octal, 4 in octal in this way. So we will again enter ones in the bit positions. So here you can see for P1 it is 2, for Q1 it is 4, for R1 it is 1 in this way. So we'll enter ones and logically OR. So this is how byte 3 is formed. So after producing all these 3 bytes, we'll go for additional seed bit generation because only 3 bytes will not give us perfect reconstruction. So we'll add additional seed bit generation. So in byte 2 and byte 3, we'll count the number of ones, which will either 1, 2, 3, or 4. If the number of ones is 1, then no need of additional bits. If the count is 2, 3, or 4, additional bits are required. And there can be trade-off between quality and compression ratio by adding bits for the count 2, 3 or count 2, 3, 4. So here we have discussed the additional bit generation. So consider the next block. We'll consider next block because in first block only the count is 1. So we can't take that block. We'll consider the next block. So next block is having these values. Again, it is converted into binary and 3 bytes are formed. After forming this one, we'll write the bit positions in the ascending order and we'll give the code. And after assigning the code for these bit positions, for example, for 3, we'll assign the code 0 and for 4, we'll assign the code 1. So we'll generate a code like 1010. So this is stored in a bit 1 file. Similarly, bit
Sorry to interrupt again, ma'am. Ma'am, you have gone 1 minute over time. So ma'am, please conclude as soon as possible.
Yes, yes. So this is
I would recommend that you just come to the results and your
results. Okay, sir. Okay. So this is how we have encoded and we have generated the bits. And similarly, seed bits are generated for the count of ones in byte 3 also and saved in bit 3 and bit 4 files. So in the decompression phase, what happens is, again, we are going to read all these files and construct B7 and B6 bits, and then we'll construct the remaining 3 bits and again remaining 3 bits in this way. So we'll reconstruct all the 8 bits of all the 4 pixels. So this is how we can achieve the decompression also. Coming to the results and conclusion. So we have taken the IEEE standard set of images of 512 by 512. So like Lena, Barbara, cameraman, tank, etc. And these are the original images and these are the reconstructed images. So here you can see the quality of reconstructed images is almost near lossless. So this is how we have achieved a very good results from this technique. And we have used a performance matrix also called as correctness ratio. So this is nothing but the number of equal pixels after reconstructing the image divided by the total number of pixels. So after using this, we have compared the results like for all these images. So PSNR is appearing to be 41.1 dB, 38.5 dB like this. This is the total number of pixels. And equal pixels using JPEG technique at the same PSNR is 50,484. But whereas equal pixels using our technique is 1,79,631. So here you can see almost it is more than double. And hence the correctness ratio is 0.19 in case of JPEG. But in our case, it is 0.68. And the compression ratio achieved is 1.45. So I will come to the conclusion. So byte transformation technique is a unique and a very simple technique for lossy image compression, and reconstructed images will be of very high quality. The accuracy obtained by this method is higher. That's the number of pixels with same value as compared to original using this method are more than JPEG approach measured at same PSNR values. And also lossless image compression is also possible by adding some more additional bits, and it uses very simple approach. And these are the references. Thank you. Thank you.
Thank you, ma'am. Sir, do you have any quick question because we are over time?
Okay. So, Madam Tanuja, I just
Yes.
want to ask one thing. What is the effect on PSNR values with your this byte transformation technique for lossy images?
So PSNR value will get based on the accurate pixels, sir. Means after the reconstruction, how many accurate pixels we are going to get. So if the all the values are correct only, then we'll get very high PSNR. So it will lead to lossless results. But here we are getting around 41, so 34. So it is like it tells the number of accurate pixels after the reconstruction.
So, in case of lossless, will this gives the same effect, or the vision technique will not be able with lossless technique?
So using this technique only, by adding some more additional bits, we can go for the lossless results also. So that also we have tried, but in this paper we have presented lossy image compression only, where compression ratio, it affects on the compression ratio. So if we go for lossless, compression ratio becomes lesser, but if we go for lossy, compression ratio is higher. Sir.
Okay, thank you. Over to you.
Thank you, Tanuja ma'am, and thank you, Paras sir. We'll move on to the next author.
Thank you, sir.
Thank you, ma'am. We have the next author is Nasreen, and her paper title is Conversion of Gujarati Alphabet to Gujarati Sign Language Using Synthetic Animation. Nasreen, am I audible to you?
Yes. Am I audible to you?
Yes, you are. You may please share a screen.
Yeah, just 2 seconds. Uh, yeah, my topic is that conversion of Gujarati alphabet to Gujarati sign language using synthetic animation. Actually, first of all, what I will cover into that, what is my proposed model, what is the standard Gujarati language literature review, architecture, and what I developed. So first of all, the research motivation I feel about that ki deaf and mute people are feeling so isolated from this world, because what is the actual problem is arise कि between the deaf people they can communicate, but when they want to communicate with the normal people they are not able to communicate, because we don't know about the sign language and they don't know about the speech, so the barrier will come. So they are feeling that isolated, so I want to means uh, 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 remove the gap between that and they are able to talk. And introduction, if I start that nearly one third of humans over the age of 60 that suffer from disabling a hearing loss. Okay. Deaf people, what is the problem as I discuss over here? So mostly the deaf people are using that sign language. So, what I want to conclude, say, as a normal people speech, so internally they converted into a Gujarati text, then that converted sign language notation, which is a hemnosis, and that hemnosis will convert into that, for example, SIGML code, and then it will convert into avatar. Mostly, why I work on that Gujarati sign language, because there are so many languages are available. Each and every region has a different particular language. So sign language also has a some variety of difference in particular sign language. So that's why there is a Gujarati sign language is used in Gujarati school, and particular that some of the words in Gujarati Kakko, Gujarati alphabets and so on. So that's why I'll work on to that Gujarati sign language. There is a book of that Indian manual alphabets, which is the Gujarati sign language, which provide a Gujarati alphabet. Now over here that Hammer sign language notation, why it is used, because it is a sign language notation which computer understand. Over here you can see that are that hand shape, orientation, location and actions. So what happened over here, that particular if I want to do a one sign, I have different particular this hand shape, orientation, location, action. I need to set that all four parameters, okay, how the particular symbol will be visible. So actually, so many work has done in this particular sign language topic. But what happened? There are some of the limitations or some of the accuracy point of view. So and it is a different why I work on Gujarati sign language because it is there is no database of a Gujarati sign language. All of that I need to create from a scratch. So I need to create from a scratch because there is no available dictionary about sign language and any digital things over here. So it work. There are so many languages: Malayalam, Chinese, Japanese, Arabic, German. These all languages are work onto that. So Malayalam to convert in Indian sign language. It in this paper it is a Malayalam text. It will take and that gives an output in Indian sign language. They are using a sign language tutoring system. Then another one it is a English and it convert into that Indian sign language. Then German, it convert in Swiss German sign language. They are using a DSGS sign gloss. Means whatever into that particular, they are using that some of hand gloves, some of that other hardware, and so on. So on the basis of that, they are converting that all things. Particular into that English too. Over here, there are 77% accuracy particular 0.8 to 5 processing time English to American sign language if I want to convert. So over here there are synchronous tree adjoining grammar is used for mapping between English to American sign language. Then English or Chinese language, they are converted into a Chinese sign language or American sign language. They are using core NLP gesture tool and using a 3D virtual human. Now, what the architecture I develop and I work on that. First of all, I will take that input speech by microphone, then that convert into a Gujarati text to one Gujarati text with that speech to Gujarati text by Python API, then Gujarati sign language. For Gujarati text means particular, for example, there is a K alphabet. So, what is the Gujarati sign language for that particular thing? Then, according to that sign, for example, the sign of K is with between two signs. So I create a Hamnosis notation with eSign editor tool. Then I will generate a SIGML code that convert that code into hexadecimal, that convert that Hamnosis symbol to hexadecimal code, and at the last that playing an avatar. Over here, there are, if I want to convert, there are two options are available. For example, there is a browser and another one, it is an eSign editor tool. So I'll convert into that Hamnosis to SIGML. The reason behind that, the avatar will play only that SIGML code. So that's why SIGML is nothing but it is an XML particular codes that avatar will understand and that play by that avatar. For example, there is a K alphabet. So for creating that K alphabet, I have this much of sign to particular Hamnosis sign that computer understand that I created a manually. I have to understand what are that particular orientation, location, and handshake. Particular each symbol there is a hexadecimal code over here. Fine, that I need to convert for that SIGML conversion. For this code, particular E009, E020, and so on, this particular SIGML code is converted and this SIGML code by playing an avatar. Now that how the accurate that my answer, I comparing my avatar with that particular standard data, how it will done. This particular all alphabet sign, there are total 48 letters. In Gujarati alphabets, there are 34 alphabets, they are consonant and 12 alphabets are particular vowels. So for that, I have converted that all that signs, all alphabets
Sorry
are
to interrupt,
converted.
Nasreen ma'am. Just 1 minute left. Can you please conclude?
Yeah, over here there are all the alphabets, and over here there are all our references. So thank you so much.
Thank you, Nasreen ma'am. Paras sir, any questions?
Yes, just a minute. According to your paper title, it's saying that you are using the synthetic animation. Which one is the other
Yeah.
method of converting this? And do you have any
Uh,
extent of those methods in your research?
yeah, actually for the synthetic animation, I'm using the just signing URL app, which are taking that input of that particular avatar. So they are converting that thing.
Paras sir,
Hell.
it's fine. Can we move to the next?
Now, am I audible?
Yes, sir. Now you are audible. Before you were not audible. That's why I was just asking.
So, okay, Nasreen, are you there?
Yeah, yeah, sir. I'm there.
So, as my question was like, is any other method other than this synthetic animation by which we can do this conversion? And do you have any impact of that in on your research comparison or
Actually,
some kind of that?
yeah, if we are moving that particular other methods of what happened actually, I'm preferring that avatar because as a person, each and every time they need to repeat that particular sign. For example, if that is particular, that avatar will play that thing, so the work is reduced.
Okay, but still you have not implemented the other method and comparison of other method with this method.
Okay, so that is means that you are asking about that avatar comparison, sir. There is a
Avatar comparison.
differentiate.
Yes, yes, yes.
Yeah. Okay. So I will implement that other method also, which and then I will compare that thing.
So that may be your future scope. Okay, thank you, Nisrin.
Yeah. Okay. Thank you so much.
Over to you, Saman. Please go ahead.
Okay, sir. Yes, sir. We'll move to the next author. So the next author is Reshma, and her paper title is Data Security in a Cloud Environment Using Cryptographic Mechanism. Reshma, ma'am, am I audible?
Yes, sir.
Ma'am, you may please present.
Yes, sir. Respected all, very warm good morning. Welcome to my session. My name is Reshma Pohankar. I am studying MCA 4th semester student. And my college naming School of Allied Science, Faculty of Science and Technology. I am representing to the Datta Mege Institute Higher Education and Research Savangi Mege Varda. My colleagues are Miss Komal Ugemuge and Miss Naneshwari Nakhate. My research guide is Professor Shailesh Gahane.
Very good morning, sir.
Hey, good morning, Professor. Good morning.
My paper ID 149 and my research topic name is Data Security in Cloud Environment Using Cryptographic Mechanism. Now coming towards the introduction part of our research paper. Cloud computing is technology that allows us to store and access data programs and services over
Reshma,
the
next PPT. Next PPT, beta.
Oh, sorry, sir. These are the contents: introduction, cryptography in cloud computing, research background, literature survey, research methodology, conclusion, and references. Then the introduction. Now coming towards the introduction part of our research paper. Cloud computing is technology that allows us to store and access data programs and services over the internet instead of using computer local storage and processing power. In this list, we help use cloud-based cryptography, one of the best method of for secure communication to stored in the cloud cryptography employs encryption techniques. These are the main application of cryptography security services are as follows. First one is confidentiality, second is data integrity, third is authentication, and fourth one is non-reputational. First one is confidentiality. A security services called confidentiality guard against unauthorized access to data. Second is data integrity. Data integrity is the responsibility of security service which must detect any alteration to the data. Third one is authentication. Authentication assures to receive that the received data has only come from a certain verified sender. And last one is non-reputational. Non-reputational is legal concept ensure that party cannot claim ownership of previous undertaking or activity. The keywords is our research paper, which are frequently find are cloud computing, internet, cryptography, encryption, information security. This is the cryptography in cloud computing where structure cryptography is given. There are three things in this diagram. So this diagram represents for cryptography. So that particular data converted from plain text to ciphertext. Then the another note that data is converted from ciphertext to plain text. So for this research background, we have studied near about 18 research paper over there that the 18 research paper, we have funded it out of 5 literature survey. So now this sender side, we are going to send the data in the form of plain text. Then this text is going to be encrypted with the mechanism. Here we have used the encrypted algorithms. The list plain text is converted into ciphertext. And then the after conversion of data to the ciphertext, descripted technology, again descripted algorithm is going to be work on another node. So the data is converted from one form to another form. Using a cryptography mechanism is the Gmail application. When the sender sends an email from Gmail, the email content and attachment are encrypted using to secure encryption algorithms. The plain text and secure encryption key produce ciphertext, which is the encrypted version of your email. Upon receiving the encrypted email, the receiver Gmail client uses the approximate descripted algorithms with the secure description keys to transform the ciphertext back into the original plain text, making the email readable to the receiver. By encryption and description algorithms allows with the proper key management. Gmail ensures that Gmail remains confidential and secure during transit and storage, protecting sensitive information from unauthorized access. This is the literature survey. Here we have 18 research paper, out of which we have founded 5 best research paper in per our study. So we have founded out the author and title, their findings and remarks. Now, first title are data security in cloud environment using cryptographic mechanism. It is a publication is a bulletin of electrical engineering and informatics. Then the findings are software platforms and infrastructure components make up the cloud resources. Then the remarks are through a process known as cloud computing, users can access an infinite amount of computing power. Then the second title are one-time pad encryption techniques in cryptography. It is the publication is International Journal of Computational Learning Intelligence. Then the findings are, in this research, we use cloud-based cryptography, one of the best methods for secure communication in cryptography. Then the remarks are, due to this, cloud computing have evolved into technological advertisement that can manage massive volumes of data that are transported and stored via electronics applications. Then the third title are cloud data security and various cryptographic algorithms. It is a publication is International Journal of Electrical and Computer Engineering. Then the findings are, due to its capacity of offer individual and organization with the access to massive resources, cloud computing technology has become quite popular. Then the remarks are, in order to protect cloud infrastructure from internal and external threats, cloud services providers must take the necessary precautions. Fourth title are design of ultra low power multifiring hybrid adder. Then the findings are some businesses encrypt their important data before moving into the cloud after becoming aware of this security issue. Then the remarks are this add an additional layer of security from the client's perspective for their data in transit. And the last one title are a review on cryptography in cloud computing. It is a publication is International Journal of Scientific Research in Computer Science, Engineering and Information Technology. Then the findings are the low cost, enhanced storage and flexibility of cloud computing are its most significant benefits. Then the remarks are computing services including things like servers, storage, database, networking and software to name a few.
Ma'am, sorry to interrupt, but it's about to be time. So can you please conclude? Just 1 minute left.
Okay, sir. Now this is the slide which represent to research methodology of our research paper. Cryptography mechanism is used to restrict unauthorized to access data, which is important use to cryptography. Cloud-based services are widely utilized at a global scale, whereas cryptography mechanism should preferably apply. So for this conclusion, this study evaluated and reviewed several different cryptographic methods used in cloud computing, including those employed by some of the industry biggest fame. It was suggested and explored it to utilization of new algorithms to encrypted data as into the transfer from the cloud user to the cloud provider's platform. Apart from this, we have suggested for four main application of cryptography, that is the confidentiality, data integrity, authentication, and non-reputational, that are the essential for information security services and suggestion process of cryptography. These are the 18 research paper which we have refer given below. So thank you for giving us opportunity to represent our research paper in your conference. Thank you so much.
Thank you, Reshma. I have one small doubt that in your literature survey, the first paper you mentioned is having the same title as your paper's title. Only a difference of A is there. Yes, this one. This is data security in cloud environment using cryptographic mechanism, and आपका जो है that is data security in a cloud environment using cryptographic mechanism. Is it?
Yes. Yes.
So, don't you think this is showing the plagiarism is the title plagiarism?
Yes, sir. Sure.
It is the
These
same
are the
title.
Yes, sir.
So you are having the same title as it is already given by some Feroz Banu and Jebizili.
It's by my mistake, sir.
So, do you have some different research on this
Yes.
title, or you are
Yes.
having the same kind of research? Because title is exact same, only one single word is different, and that is also one character A. Shailesh sir, can you give some? Can you put some light on that?
Hello, Shailesh sir.
Yeah,
Yes.
sir, actually it is by mistakenly it is happening from our side. So actually this data security in cloud environment, which is we have mentioned here in reference number 1, actually it is by mistake. It is
So
our mistake.
which title is not correct, Miss? The
This
author
mentioned title is not correct, sir.
this title is not correct. Literature survey title is not correct.
Yes, sir. Yes. Sir.
Okay. So what is that title? Can you give the title?
For the literature survey?
Yeah.
Yes,
What
sir.
is the
Just
title
wait.
of paper given by Feroz Banu and Jebizili?
Yes, sir. Just wait. Just a minute, sir. I'm telling you.
So no issue. Please submit the title to the What body and
Sir, it's a data security in cloud environment with the electrical engineering technology.
okay, and you are using the cryptographic mechanism. That
Yes,
is
sir.
what?
We are using the cryptographic mechanism.
But in electrical engineering, how they are giving the findings of software platform and infrastructure component of cloud computing?
Sir, they have invented some new mechanism related to electrical component, which they are using their technology related to electrical technology. So here we have find it out in reference number 1. We have find it out the data security component, which
Yeah,
Reshma elaborated on the
I think in
confidence.
this literature survey, the findings and remarks are also, I think some big misunderstanding happened there. So please rectify that and give
Surely,
the
sir.
correct version to the team.
Ji, sir.
And
Sure, sir.
IST team, please.
Yes, sir. Sure, sir. Sure, sir. Thank you, sir. Thank you very much.
Okay, thank you, Reshma ma'am, and thank
Over
you,
to you.
Paras sir. Also, thank you, Shailesh sir. So we'll be moving to the next author. So next, next author is Shishir Singh, and his paper title is Effective Detection of Liver Disease Using Machine Learning Algorithms. Shishir sir, can you hear me?
Good morning, sir. Can you
Good
hear me?
morning,
Am I
Shishir.
audible, sir?
Yes, yes, you are audible. You may please present your screen.
Yes, sir. Just a second, sir.
Yes, take your time.
Is it visible, sir?
Yes, it's visible. You've got 8 minutes. You may start.
Okay. Thank you, sir. Good morning, everyone. This is Shishir Singh, and today I am going to present my topic, effective detection of liver disease using machine learning algorithms. These are my group members and my guide, Mr. Amal Dumane, sir. So basically, the contents that we are going to go through my project are the introduction, problem definitions, and as we move on in the slides. So basically, liver disease detection is one of the projects that we have taken due to various reasons. And one of the things is that liver is one of the most important parts of our body, and we can predict that someone may have liver disorder or not based on various types of symptoms that he is having over his body due to those due to the liver diseases happening. And they can be such as loss of appetite, jaundice, itchy skin, dark urine color, and various reasons. So basically what happens is that when we use a machine learning model, which is the main core of our project, building a model through machine learning helps to extract important data from the from the actual data that is given, which can be in any form, numerical form, or it can be also in the photographic form. So basically, we are taking here the numerical form in which we are going to work upon the data that is being given. And there are maybe different types of characteristics or complex structures of the data set, which can be difficult in order to predict the accuracy. So basically, to get the answer of if a particular person has liver disease or he does not have liver disease is really tough in terms of determining at an early stage for a person. So with the help of machine learning models, we can actually do that. So our problem definition was developing an accurate and efficient machine learning model to detect liver disorders in order to aid early diagnosis and timely treatment of liver diseases. So the motivation were basically that the liver disorders can lead to severe complication and significant impact in a person's quality of life. So basically, liver is actually responsible for many types of functions that can be performed inside a human body. But if it has been affected by certain reasons, there can be a lot of malfunctions in the body, and there may be loss of performance due to which a person cannot feel to his own very best. And liver disease prevention is really necessary in order to make let a person live, because it can have a lot of risky impacts on that. Timely intervention and management of liver disorders can improve his patient's outcome and increase in the survival rate. When we can with the help of the early detection, it can help him in order to get better medications at an early stage of his life, because certain times the liver disorders at an early stage cannot be detected and as such. So basically, our objective was to develop a machine learning model for accurate and early detection of liver disease. So when we start detecting a liver disease from that, we go by finding out various accuracy score or the prediction score from the basic models, and then we compare them with respect to that, increasing the efficiency of liver disease diagnosis by implementing automated detection system. So basically, when we use the machine learning system, then after that we can go on to the front end with providing certain way in which we can actually show that if the particular person has that disease or not, enhance the patient's outcome by enabling timely intervention and reduce the healthcare costs as well associated with the healthcare cost actually reduces due to the early detection. So these were some of the references or literature survey that we took from various sites. Although the machine learning scheme is really new to the place, and due to its uh, not really more amount of experts present, there has to be certain way in which it is done. So computer topography segmentation is a certain way in which the machine learning models can be implemented with the help of all the types of data that can be image related or numeric related. So this is one of the papers in which the pre-processing combined with operation was combined with specific machine learning model for medical image analysis, wherein herein the image analysis was taken into consideration. But one of the major things that we got to learn from this paper was the pre-processing, the different ways in which the data that we get that may contain of many type of noises or many type of unwanted data. So the way in which we can reduce those noises or remove those kind of unwanted data is what we learned from this paper. And also the way in which they structured their outcome was really nice to learn from. So the next one was the radionomics model for prediction of collateral. Uh, Basically, in this, the radionomics model was basically used in order for when it is a type of like when you use the CPR machine or something like that. So what actually happens is that the hypothesis is particularly taken into consideration, and at the initial staging the computer tomography potentially identifies the risk of development of that particular diseases in a particular patient. And then there were different transplant techniques also which are used in order to data driven develop a predictive model. And herein we took the predictive model idea from which we actually went on to try and implement it in our paper. It was showing discrimination power in predictive post-predictive survival. So basically, the algorithms that we used in our paper were three, and they were the logistic regression, random forest, and support vector machine. And they are as follows: that like logistic regression is a supervised learning algorithm that is used in order for classification technique, and it can be used in order for continuous and categorical variables. The model's relationship between dependent variable and one or more independent variable is used in order for the logistic functions, and the binary outcome is the one where the probability estimation takes place on the predictions for the particular data present. And it can be interpretable, because of which it can go with both continuous as well as categorical features. This is the regression technique that we has used. Then we went on for the classification as well, wherein we used the random forest technique, which is an ensemble learning algorithm. It is used in order to combine multiple decision trees. So what actually happens is that the number of decision trees are a lot, and because of which there are data has been divided, because of which the divide and split technique is being used, wherein different types of trees get different types of data in order to act upon it, which helps in reducing the work for as a whole, and the division of the work helps in better accuracy predictions. And the third one was the support vector machine that we use, the SVM, which is a powerful supervised learning algorithm. And it basically uses a hyperplane, which is used in order to separate the data points. Like the two type of different data would be separated by a particular line, which can be the differentiating factor for that. And it is able to handle both linear and collinear tasks. So here were our results as well, and we had a chart for result for all the, although we were only looking for the precision and the accuracy scores, but we went on for the recall and F1 score as well in order to study our data much more efficiently. So the algorithms that we had, support vector machine, random forest, and logistic regression, the accuracy score of the random forest, as you can see, is the most that we have got from our particular data. Accuracy score is used in order to define the number of correct predictions by the total number of predictions. I'm really sorry for that. It is defined as the number of correct predictions to the number of total number of predictions. And then the precision score as well as recall score as well as F1 score was given, wherein the precision score is used in order for the evaluation metrics, and it is defined as the true positive upon true positive plus false positive, which is a liability of model to identify the positive instances of the data that is present with us. The recall score is one which is the evaluation metric wherein we use the concept of true positive upon true positive plus false negative. It is a sensitivity or true positive rate, which you can say that it counts out the positive instances that are particularly present inside a particular data. So the positive instances help in finding out the plus point of the data. When we go for the F1 score is basically the precision and the recall score value, which is divided by its sum. So these are the ROC.
Sorry to interrupt, sir. Sir, it's time. Can you please conclude?
Yes, these are just the ROC curves that are used in order to provide the true positive versus false positive rate of all the models that we have. And these are the graphs where we have compared the models. Okay. That's from my side, sir.
Para, sir, any questions?
Yes, can you go through your of this paper research, outcomes of this research?
Just a second, sir.
Yeah.
Yes, sir.
So here you have taken the F1 score for all these three algorithms are almost similar, right?
Yes, sir. Yes, sir.
So what is your conclusion over there?
Sir, F1 score is actually close to similar, because what happens in F1 score is that the pointal decimal values have been really reduced, because it is the multiplication of the precision as well as the recall score by their sum. So what actually happens is that it reduces to the closest nearest value, and the support vector machine and the random forest have a accuracy that is closer to each other. And in terms of the precision and recall score, they also have a better values. That's why due to F1 score, it is balanced. That's why they are similar to each other.
Okay. But in this case, if we see, so I think we can logistic regression can be left as it is to get this result, while these two results having very similar score, F1 score. So out of these two, which one you will say that it will give the better performance in terms of machine learning exams?
Sir, I would say that random forest will be the one, because when the number of data, the amount of data increases, what actually happens is that random forest has is actually helps in dividing the problem by reducing the number of complexities that would come inside a particular model. It divides it into decision trees, and what happens is that each one of them handles certain amount of data. And then after that, we can work on it. That I will say that random forest should be the one that I will.
Right, true. But as your results is also showing that the accuracy score and precision score are better in case of random forest.
Yes, sir.
Thank you. Thank you, Shishir.
Thank you. Thank you, sir.
Thank you, Para, sir, and thank you, Shishir, sir. And let's move to the next author. So the next author is Ishita Patel, and her paper title is Online Meeting Summarization Based on Text and Image Processing. Ishita ma'am, can you hear me?
Good morning to one and all. As there's a small mention, Ishita Patel couldn't be present for the conference. So on behalf of the entire group, I, Ishita Sharma, will be presenting the paper.
Okay, Ishita. You may please present your screen.
Yes. Is the screen visible?
Yes, it's visible.
Yes. Good morning to one and all. Our paper title is Online Meeting Summarization Based on Text and Image Processing, and our group members are Prutha Kurtarkar, Bishop Julka, Ishita Patel, and myself, Ishita Sharma, under the guidance of Professor Bhakti Sonavne ma'am. So these are the table of contents. We'll be going through all these things through the PPT. So introduction. So basically, the system that we have researched upon, it's basically a summarization system, wherein it's a meeting app where whatever the person will be speaking first, whatever the person is speaking, the entire thing will be transcribed and it will be visible on the bottom. And if we can also determine whether the entire meeting was on a positive note or a negative note. The second thing is that the system is basically based on factors such as the speaker turns, basically who is speaking at what time, like at the particular moment which speaker is actually speaking, sentiment analysis, key visual elements, and using all these factors, there's a comprehensive summary of the meeting that is being given at the end of the meeting. um, so basically after the meeting is over, all the participants and all the people who have joined the meeting, they'll get a quick review of what has been done in the entire meeting. These were a few papers that we had researched. The first one is analysis of facial emotion recognition, which consisted of emotion recognition and support vector machine. But the gap in that paper was that there was no sentiment analysis in that paper. The second paper was a survey on NLP based text summarization of summarizing product reviews. This paper consisted of text summarization, product review summarization, and NLP techniques. But the gap was specific domain specific was not available, and real-time text capturing wasn't available. The third paper is multi-document text summarization, a survey. This paper consisted of this paper captures multi-document text and text summarization, but user face detection and sentiment analysis wasn't included in it. The fourth one is keyword extraction from educational video transcripts using NLP techniques. This paper consisted of keyword extraction and text summarization, but sentiment analysis and real-time text capturing wasn't present in this paper. The fifth one and the last one is real-time employee emotion detection system using machine learning. This paper consisted of emotion detection, facial expression analysis, and machine learning, but text capturing and summarization wasn't available in this paper. We have also compared our system with the different applications which are already available. So the applications which are already existing and are being used are Microsoft Teams, YouTube, Zoom, and Otter AI. Now there's a quick we have just presented a quick differentiation between all of them. So in Microsoft Teams, you can give control to the other person. Contents can be shared and collaborated, and the attendee video, audio, and the reactions can be given. But sentiment analysis and the meeting reports aren't available on Microsoft Teams. The second one is YouTube. YouTube supports transcript of the video, and live video sharing is also enabled, but video chatting facility, sentiment analysis, and meeting reports cannot be generated from YouTube. Zoom transcript is supported and live video can also be shared, but it does not support facial sentiment analysis and meeting reports. Otter AI, live transcript, sentiment analysis, and live content sharing is supported in Otter AI, but it does not generate meeting reports. So basically, the problem statement of our research is to make sentiment analysis through video and audio by analyzing the facial gesture and converting the audio to text and analyzing the summarized text. The objectives are to create a video meeting application for conducting meetings, to analyze the facial gestures of participants in the meeting and to predict the outcomes of the meeting, to analyze the communication between participants in the meeting and predict the outcomes of the meeting, and summarizing the points discussed in the meetings and creating the minutes of the meetings. The scope of the research is making analysis on basis of facial gesture, making analysis of the meeting based on summarized text, creating minutes of the meeting, and predicting the outcomes of the meeting. So text summarization can be broadly classified into these three types, which is based on the input type, based on purpose, and based on output type. So we have basically concentrated on based on output type, and in that there are two methods, abstractive and extractive, and in this we have basically concentrated on extractive methods. A sentiment analysis, here sentiment analysis can also be broadly classified into these four categories, and here we are basically concentrating on emotion mining. So this is the system architecture of the meeting summarization, the meeting app that we have used. Basically, we have used the Agora server to create the meeting interface. So basically, when the link is provided to like the host creates a link first, and after he has created the link, he'll be sending the link to all the participants. So basically what happens is whenever the meeting link is created, the token using the channel role, token type, and the user ID is first given to the server, the token server. The token server then will then be evaluating that token internally, and then he'll be returning he'll be generating the token and giving it to the client. This was when the client was requesting for a token. He validates it and then he gives out the token, the server gives out the token. After that, the Agora server will be validating the token, and then the participant will be added into a meeting, the respective meeting, since if there are multiple meetings going on. So in which meeting the participants need to be added, that will be taken care by the token, like the token will be validated. And in case the meeting stops, or when the token expires, the same thing will be carried out again. The token will be requested, it will be validated, and the token will be generated, and it will be given to the client so that he can get into the correct meeting. So basically,
sorry to interrupt, ma'am. Just 1 minute left. Can you please conclude?
Yes, I'll be winding it up now. These are some of the snapshots of what we have created. So I'll be winding it up by just showing the snapshots. So basically, whenever the link is given, the first thing that will be seen is join the stream. After joining the stream, when all the participants join, we'll be given these buttons on the bottom, at the bottom. So basically, leave stream if you want to leave the meeting, mic just to turn on or turn off the mic, camera to turn on or turn off the camera, face detection, if you want to see the face detection of a particular person, you can see that using this button. And to summarize the text, after clicking on this button, whatever has been discussed in the meeting, that will be summarized into a paragraph. This was the mobile view. So this is basically the face detection. Whenever a person clicks on show face detection, he'll be prompted with this screen, wherein he or she will be shown whether that person is happy, sad, or in what kind of emotion is he actually in right now. So in the previous slide, she was happy. In the second, she's neutral and sad. So these were the facilities that we have used to create the entire app. And this is a small analysis of our system, Teams, YouTube, Zoom, and Otter AI. This is the final summary of comparison between our app and the other available apps in the market right now. So basically, to conclude, I'll say it's just a meeting app where you can conduct meetings. The transcript will be available at the bottom. At the end, you can get a text summarization, and also you'll get the emotion, the sentiment analysis, and you can also use this text summarization to create the minutes of the meeting. So basically, this will help to improve the efficiency and to manage the projects or whatever is happening on the meeting, to basically manage everything. These were the references that we had, papers that we had referred. And thank you so much for listening to this.
Thank you, Ishita. It was a nice presentation indeed. One
Thank
thing,
you.
one confusion which I am having, that you have considered YouTube as the online meeting tool.
Yes, sir.
Do you really think that on the features which you are offering in through your paper can be carried out by YouTube?
Sir, basically, actually, to talk about YouTube, YouTube is not an online meeting. It is basically you post your videos and it will be seen by the other people.
It's
Also,
for
in
live
YouTube, there
streaming only. YouTube is for live streaming only, I think.
yes, sir. YouTube, yes, that is what I was coming on, sir. This is this is first part of YouTube, and second part is you can also share your live videos. Like there are so many YouTubers, and they play online games or whatever it happens. They are sharing it on live basis. So you can chat. Like there is a chatting section, live chatting section. Um, in the in at there is a particular section where you can chat, but sentiment analysis and the meeting reports are obviously not created in YouTube. So just for the comparison, because even ours is a online, like live sharing app, and YouTube also supports that facility. So just for that reason, we have also included YouTube in this.
So summarizing the live streaming or video and summarizing a meeting may
Yes,
have
sir.
some different parameters to right?
Yes, sir, because in a meeting there is a two-way communication, but in live streaming there is only one way, like only
Very
the
good.
host is speaking.
Yes. So can we take the YouTube as the online meeting or summarization tool in your paper title? So do you think, really think this is the right example to parent to include in your research?
Sir, actually, as you say that YouTube isn't a meeting platform because it is a one-way communication. Yes, accepted, because in YouTube only the host is sharing his video, but because even that is a live video sharing application, so we just thought that even YouTube could be included in it, because even YouTube has the facility of live video sharing, and all of the other applications have. So because it was even though it was a one way video sharing app, but we still thought that it could be included, because it is still like a video sharing app
So how
after all.
image processing can be happened in the video?
Sir, to summarize the entire, like there are a lot of videos on YouTube. You can actually there are videos where if any kind of abusive things are being said on the video, or
That
any kind of, if the video is not appropriate, so if that,
slang words can be taken
yes sir.
by the text processing also. What
Yes
I'm
sir.
asking is image processing. How image processing will contribute in YouTube video streaming?
Sir, you can summarize how the, like if live video sharing was to be considered, it can be used to see that how the entire live streaming was, like the host, the expressions of the host, if it was aggressive, if it was neutral or happy, what kind of live video sharing it was overall. So that could be done using the uh, uh, sentiment analysis.
Okay, so I think you have to put some more efforts for this on this, and wish you all the best. Thank you.
Okay, sir. Okay, thank you, sir.
Thank you, Para sir, and thank you, Ishita ma'am. So let's move to the next author. So the next author is Vaishnavi, and her paper title is Plant Disease Detection with Learning-Based Models. Vaishnavi ma'am,
Hello, am I audible?
yes, you are audible. You may please share your screen.
Yeah. Yeah, my videos share.
Yes, it's shared. You've got 8 minutes to start.
Okay, hello everyone. My name is Vaishnav Chillar. I'm a student of KL Technological University, and the paper ID is 10. My paper title is Plant Disease Detection with Learning-Based Models, and my co-authors are Dr. Sunita V. Budial and Dr. Saroja V. Sidmal ma'am. Yeah, these are contents of my presentation. Introduction. Uh, in our society, we can't grow plants in the small bunches. For to be industry level, it should be built in a large scale, and identifying like diseases in them is very time consuming. That's why we go for automation in that. And these are some literature survey we gone through for detecting what are the problems we face while going for automation. My first paper uses machine learning for detecting disease in plants. They have used random forest for classification and hawk for image processing. In that, we learned that small data set affects the accuracy. They have used like small number of plant images, that is 160 images. And my next paper is image-based plant disease detection with deep learning. In that, we have learned that extracting our features from neural networks, with that it learns faster, so time will be less consumed here. And in my next paper, that is soybean plant disease identification using convolution neural network. In this, they have used 12,000 images. We can learn that basic algorithms are gives high accuracy when data is pre-processed, because pre-processing the image is more important than choosing an algorithm. And with the next paper, that is deep learning models for plant disease detection and diagnosis, computers and electronics in agriculture. In that, they have used like 87 plus K images. In that, we have learned that we have to train our model for different possible conditions, so that the accuracy will be more. And our problem statement is performance evaluation of VGG19 and 14 DCN model for plant disease detection. We are going for VGG19 and 14 DCN. I'll tell you in a later process. The objectives are to comprehend the convolution neural networks and put deep models into practice to detect our plant disease using leaf images, and to compare models in different circumstances. This is my proposed methodology. The steps are for any models, we go for the same process, that is image pre-processing and image augmentation, then training dataset with different models and testing our data. Why we go for image pre-processing? Because to reduce the noise from our images, and with image clipping and cropping, the desired area of leaf where the smoothing is needed, we can do that, and it will enhance the contrast. And for with image augmentation, in literature survey, we know that number of images are required to get a better result. That's why we go for image augmentation with shear range and zoom, horizontal flip, T-scale. We can achieve that. For that, we have image data generation API. And in our neural networks, the basic building blocks are convolution networks that transform the input image in order to extract our features. This is my equation for that. My input image width and output image and states, and the frequency of channel. In pooling layer, in pooling layer, the size of feature maps is decreased, so that it will reduce the amount of work it needed to be done. And the next one is flatten layer. It will aggregate all the two-dimensional array into one single, so that it will reduce our time. And in dense layer, we use our ReLU as our activation function, because it gives non-linearity in our model. And softmax in my last output layer, because for multi-class problems, it is the activation layer for ideal. And this is my VGG19 model proposed methodology. In this, the 16s are convolution layer and 2 fully connected layer and 1 last softmax dense layer. In that 16, my I have like 5 max pool layers, which will give me outputs. Algorithm for that proposed layer VGG19. We have to start our VGG19. First, we have the image should be pre-processed with and augmented with rescaling, zooming, and flipping, and it should be divided into 80:20 split as my training and testing data set. I have used apple, cherry, corn, grape, peas, and strawberry and potato, 7 classes of plants to test. And I have used 18 plus 18.5K plus images for training. And for VGG19 model, it is trained using leaf image datasets, and the weights are generated according to, and these history is used and to generate confusion matrix to detect the accuracy of the model. This is my next model, that is 14D CNN model. In that we have contained 14 layers, and in that 10 are convolution layer, that is 5 are convolution layer and 5 are max pool layer, and 2 fully connected and dropout, and 1 more dropout with softmax layer. This is a novel model. This paper is published before that to understand how convolution layer is with 14 number of layers, how it is extracting desired features. The
Sorry to
algorithm
interrupt, ma'am.
Yeah.
It's just 1 minute left. Can you please conclude?
Yeah, algorithm is same for both but we are using 14DCN algorithm here. This is my summarized architecture. The specification for is for VG19 model is the hyperparameter is 32, and we use Adam as the optimizer. And as previously said, activation function really we have used. In this slide we get to know how my dimension of my image is going to vary with those equations. For 14D CNN model, these are the specification. We have used dropout layer value as 0.2 because that will give me better results. We have tried for different values, and for hyperparameter we have used 32 batches. These are data curation. These are the set of example images we have used for training and testing. The dataset distributions is important to understand. As I said, data is important in any neural networks problem. And these are some results of data augmentation we have used. And this is a accuracy graph for my VG19. As you can see, as my accuracy of my while training is more than my testing, so that data is important while training also. This is my 14D CNN model. Here the value of accuracy while training and testing is mostly similar. I have used VGG19, 14D CNN, and inception with and exit for testing all the different plan set, 7 Blaze plans. In that we for small number of data sets, 14D CNN model is ideal because it gives all the correct output with better accuracy. But my VG19 that uses transfer learning, that gives me better result when my data set is more. These are the classification report. It gives me precision, recall, F1 scores. This is my graph for that. These are some results when the model recognizes the disease and misidentify the results. For previous one is for VG19 and it is for 14D CNN. And these are some comparisons. As I earlier said, for 14D CNN model outperforms VG19 for smaller data sets. And VG19, as it is used transfer learning, it will take more time than 14D CNN as it is from scratch. Memory wise also VG19 uses more memory. Conclusion, VG19 performs for well outperforms for small data sets compared to VG19. The future scope is we can go for different deep learning module and expect some more good results. These are some reference. Thank you. Yeah,
Thank you,
I'm ready for
Vaishnavi.
feedback and queries.
Paras sir, we go for one quick question because the speaker has exhausted her time.
I think so. So thank you, Vaishnavi.
Yeah.
Please proceed to the next.
Okay,
Should
sir.
I
So
stop?
question
we
from
can
my side.
have one
No question
quick
from my
question
side.
if you want.
So no question from my side. Please. go.
Okay, sir. So then we'll move to the next.
Please.
Thank you, sir.
Thank you, Vaishnavi ma'am.
Thank you, Vishnu.
So the next author is Darshan, and his paper title is Road Lane Line Detection. Darshan sir, can you hear me?
Yeah, I can hear you, sir.
Yes, sir, you may please present your screen.
Thank you, sir. Cool. So a very good morning to everyone. My name is Dr. Darshan Ingle, and I am the project guide for the students Shri Srivastav, Pratham Shah, and Bhavya Sheth. So they are our final year students, and unfortunately, because they have the office schedules and their work has started, so I'm delivering on their behalf. So I'm the fourth author in this research paper, and the topic is road line detection. So let's get started.
Sure.
So with the growth of the urban traffic, ensuring traffic safety is becoming an increasingly significant factor. And there should be some advancements in the technology with the help of which we are able to achieve the goal of traffic safety. Diverging a car from a road lane increases the chances of the accidents and other causes on the avenues. So the prime motive behind the equipment of the vehicles is integrating it with some advanced tools to ensure safety, lessening the road accidents, and maximizing amenities and contentment for the people and the driving experience. And most of them, if you observe, they can be easily achieved by identifying the road lanes, which becomes the most important thing. So yes, so lane discipline is again another thing which is very important for the drivers. In fact, we do have various high-tech research and studies which are going on in this domain, considering the road and the people safety. And our project, Road Lane Line Detection, mainly aims to demystify these issues by detecting the lane lines on the road and providing directions to the drivers based on the lane markings. So the problems which we have solved by this proposed model are: number one, reducing the road accidents because of departing lanes. Second, contentment to the people sitting behind the driver. Third, reducing the driver fatigue. Fourth, improving on the traffic safety conditions. Fifth, we can also think of ADAS systems like autonomous driving, which can be enabled because of that. Then sixth one would be providing directions while driving a vehicle and detecting the lanes during almost every weather condition. So we have tried out all these things and we could get comparatively better results than what we found in the earlier research paper. So our paper is not something very new, but surely a refined approach to the older one. Now, to give you a quick heads up on the literature review, most of the previous research papers were having the approaches which detect the lane centers and not the exact left and the right lane boundaries. Plus, they also did not consider the various amenities provided by the system. So we have seen that there have been various researchers who have been using the deep learning and the image processing techniques. Some of them were also, including the Gaussian smoothing, half transform, convolutional neural networks, and all of these are undoubtedly the state-of-the-art techniques, but somehow we plan to improvise the results of this. So our paper mainly focuses on improvising the model, like capturing the road lens, detecting switching of the lanes, which are bound to happen in the near future, and also detecting it under noisy conditions as well as during the low light conditions. I'll directly dive on now to the methodology of our project. Well, if you see, right, so the entire process of the road lane detection, we have divided it into two parts. The first part is what we call as the pre-processing, and the next is the post-processing. The pre-processing phase mainly focuses on preparing the image for subsequent half transform. So it mainly involves a total of 4 steps. Image selection to filter out the lane lines, grayscale conversion, where we are creating a monochromatic image. Then we have the Gaussian smoothing to reduce the noise and the relevant data. And finally, we have the canny edge detection to generate a binary image representing only the edges of the elements in the image. Now, see, these steps we found to be very important. And it's not that these all steps we have come to a conclusion in a single go. There were a lot of hit and trial methods that we tried in and around. And finally, we could boil down to these all 4 steps. So I can say that these steps were crucial for the successful execution of the last pre-processing step, which is our canny edge detection. And once the pre-processing is done, our post-processing phase starts over here, where we'll be having the half transformation and the direction detection process. Half transformation and the direction detection process. Well, before applying the half transformation, the region of interest is extracted from the image, and the output of the half transform is then compared with the output generated by the image segmentation phase, which mainly focuses on the histogram analysis of the actual lanes to enable the directions. So obviously, if I just have to give you a little bit heads up on that, well, we know that if this is the road lane, obviously, or I can say over here, like, this can be the road lanes. So we have created a histogram of various road lanes where it is quite obvious that the shape of the histogram is going to be peaked in this region as well as peaked in this region. Depending on, if the road is having, let's say, a curvature over here, we will have it like this. So I have all of these things in the next slide where we will be going through this, but as of now, right? So yeah, as you can see, right? So sometimes this line are brighter and these are darker. We have aimed to successfully capture the trapezium structure over here. So I was saying that once our pre-processing is done, our post-processing consists of 2 things, right? One is the half transformation and the second is the direction detection process. So before I applied the half transformation, the region of interest is extracted from our image. So we have the grayscale and the Gaussian smoothing. And then as you can see, right, from this, we are having the canny edge detection in the picture. Then from here, we can clearly see that we have applied half transform. So if I reiterate you through the steps, right? So we have filtered out the lane lines. Then our grayscale conversion was done because color image was having too much information and we were only interested in the information related to the lanes. And the next important thing is over here, the complexity of the image was also reduced, and that is the reason we converted it to the grayscale. And then we finally had our...
Sorry to interrupt, Darshan sir. 1 minute to go. You may please conclude.
Yep. Sure, sir. So yes, after this, we go for image segmentation so that we can extract the boundaries, which gets us the histogram. And finally, from this histogram, we are able to detect these lines. So precisely, the region of interest is extracted from the image, and the output of the hub transform is then compared with the output generated by the image segmentation phase, which focuses on the histogram analysis of the actual lines, which helps us to analyze the directions. And then the hub transform output is further improved by the Kalman filter model, which enables the algorithm to effectively operate in the complex environment. So yes, these all things help us in the overall working. And post that, I'll directly now dive into the results section for you, where you can see the left side, right, which represents the output which is generated by the half transform algorithm in a clear weather condition based on the inputs given by the pre-processing model. And the lines you can see are mapped with the initial image to compare the line generated with the actual lanes. So it shows the predicted direction on the top right corner, as you can see, right, left, right, and straight. And if you see to the right, we have also considered some critical weather conditions, which shows the predicted lanes are still quite decently detected. And we can see this based on the predictions. So to conclude, my dear friends, I can say that yes, existing road lane detection solutions are inadequate in terms of optimization and efficiency and robustness. Our model addresses these issues such as nighttime lane detection, which obviously gives an advantage of reducing the road accidents and enhancing the passenger contentment. Right. Then, obviously, Kalman filtering overcomes our night detection by predicting the lane markings based on the previous results from the hub transform. And the future scope, yes, what we are working upon at the moment is somehow trying to gather all of this information in the form of a visual data set and train a machine learning model which can help us in further predicting the accuracy of the system so that we can make this model actually deployable. So right now we are over here. So multiple lane detection is the another thing that we are planning, integrating with the cameras, integration with AI. And yep, that's pretty much it. So thank you very much, team. That's all from my side. Any questions are most welcome.
Thank you, Dr. Darshan. There is one quick question. It is not one question based on your paper, but what do you suggest? Can we make some changes in the hardware or equipment implemented on the lane? And by that, instead of machine learning and instead of fixed robotics, can we make some changes in the color of the lens thing and lights? We can put some lights for the late night detections. So if they can prevent accident, so I think we can do that. So I just want to know your view on that. Although as you are from the computer side and you are implementing it with the information technology, but what I suggest that can we do it without information technology?
Since that's a pretty good suggestion, I would say, but no, completely ignoring the IT part of it and going ahead with complete hardware, we doubt the reliability of such a system. Today, if you observe, sir, every system that we have in the basic or the most basic automobile industry, right? Automobile which is running on the road, everything is integrated with the help of sensors, right? We have the ABS, EBD, everything very well functioning. And if we are actually deploying this thing with the help of AI and the sensor technology, the advantage that we will be getting over here is some confidence or faith in the system with the help of which we can predict, because there may be some situations wherein the model is likely to fail. And in such cases, we don't want it to get into some fatal state. So to avoid all those things, somehow, if you have a model which has already seen some of the past interactions like that, and if it is integrated over here, the car can take a decision of approximating what is going to be the lane which it should follow, or coming to an halt so that it can get a better picture. At the same time, ensuring that the vehicle which is coming from the rear is not dashing upon me. So, consider the conditions like the fog conditions and all. So in such cases, I think having a predictive model is the only thing as of today. And considering the fact that today generative AI is ruling the world, I think it is highly recommended to have the integration of hardware as well as software together to get the best out of this particular model.
Okay, so very true. It's not about the ignoring the ICT and generative AI. It's all about the economic feasibility, you must say, because we are having every day we are making a way pathway on the road section. So putting all the instruments and these machineries on the entire road structure, I think it's economical not feasible in this condition for India. So that's what I was thinking. Do we know the another approach in which we can take the hybrid model, like some of the parts we can integrate with this technology and some of the parts we can go with the traditional methods, and we can make some hybrid model by which we can we can follow all those things, like we can reduce the accidents, we can keep the automobiles running on accurate and fast speed and everything. So that was what my concern. But
that's a very good suggestion, sir. I will surely think about it. In fact, we will surely discuss on this. We'll have a quick meeting regarding this, and I'll ensure that somehow we are trying to integrate. Basically, I understood your point of view, right? It should not be a complete reliance on the information technology, but hardware should also take care of it, and it should be cost efficient.
Cost efficient. That is very
right. Yes. I mean, that's a very good suggestion. I have noted it, sir.
Yeah. Thank you.
Thank you, sir.
Dr. Darshan, thank you very much.
Thank you.
Thank you, Darshan sir, and thank you, Paras sir. We'll move to the next author now. So next up we have G. J. Sridhar, and his paper title is Smart Glasses Designed Using ESP32 Cam Coupled with Google Lens. Can you hear me?
Yes, I could able to hear you. I just had a screen. I guess the screen is visible, sir.
Yes, it's visible. You may start here. You have got 8 minutes.
Yeah, thanks, sir. So I'm Jay Shriya. I'm from Rajasthan College. So our title is Smart Glasses Design Using ESP32 Cam Coupled with Google Lens. The thing is, we are creating a new smart glass which will be affordable and will be using for disability people who are having a blind or eye disease. And the paper ID is 163. So we have the outline of what is the overall thing, like what are the systems we are going to just go through in this PPT as well as in the presentation which I'm doing. So on the side we will be having what is the ratio of the thing of global eye diseases we are facing in this current situation. Like not everyone is blind, but maximum people are having like due to age they cannot able to visualize the image or they could not able to see the image. So we are also having a working over that. So the thing is, like around 39 million people who are in the world is blind, and other 284 million people are visually impaired. The visually impaired includes of the people who are due to age and due to some other reasons, genetics and other things. And the major thing in our the major thing which we are focusing, like what is the main cause of creating that thing is, we need the people who are disabled or not freedom to go on themselves, or they can take their own decisions, or they just go with their own format. They need someone's support. So to reduce the support, the amount of support which is being given should be reduced. For that, we are just going to implement and we are designing the system. So as an example, like in Kerala in the year 2020, we had an incident like no one has helped this blind man, but a woman has just taken action and she has just put forward herself and just go through with this. And the people just make it as a viral, but not they are thinking like what is happening, like why no people is just interested in doing help with a blind man. So the thing is how the people are mostly dependent over the society. So the major objective is like these technologies are kindly available in the market, not around India, but it's mostly available over the other sides of the eastern parts. So these are very costly. Like it costs a minimal of $1,500, which will be around like more than 1 lakh in Indian rupees, which will be like very much higher in the cost for the people who are disabled. And the government is not like with helping the people with this much amount. They can help their side, but not on this amount. So we can reduce the cost on, we can just put what is the necessary things. And these smart glasses are just like on an initial stage, companies started to make the smart glasses for blinds and the people who are having disabilities. And further, they started to make it as a business. So they started to make it as a for the people who are having a normal life. So they just created a smart and VR glasses only for the normal people, and they just started to ignore of the blinds. So we have a proposed model, like we have made a system which will be just using a camera and the internet IoT and the Android phone or any phone which will be connected to the internet, so that it will be recognizing the image. First, a trigger button is given. So the thing is, the whole system which will be having a trigger system. Once a trigger is pressed, the camera will be operated and the image or a text is captured by the uh, camera, and it is being recognized, and it is being converted to the text or the object sound. So which is done through the Google Lens. Since we are not using a pre-trained model or other models, since it's a visualization of object in the world is very huge. Like we have n number of objects and n number of text, n number of numerous, like we have many things. We cannot just go into a simple like in a research, we cannot just put into millions of documents into it, and we cannot train it. It's a very difficult thing, and we need a very huge servers. But Google has done this, so we can utilize them as a research purpose. We can utilize on a commercial. It will be on a different side. So the thing, what we are exactly doing. So the first left side graph shows how it is being working. So whenever the blind people require some assist, they just press the trigger, and the image will be captured, and the processing, how it is being, the image will be sent to the Google Lens, and the Google Lens will be converting the image to audio or the text to audio, which will be taken care of MacroDroid. MacroDroid is another supporting version which will help in automation of Android. So we are using MacroDroid, and it is being converted into audio output. And on the MacroDroid, how it is being working out there. The MacroDroid is an app or an application which is used for automation of systems in Android. So we can preset the MacroDroid to the function which we are required. So the MacroDroid will capture and get to the server. Like where is the ESP32 is capturing from the server, the image is gone through, and through that the Google Lens is being Google Lens is getting the image from the server, and after that we are detecting it whether it is a text or an object. So that according to the text or object, it will be getting towards the text, means it will be converting the text into audio, and directly it will be converting into audio file. Or if it is not text, if it is an image, the image is first converted into, first it is recognized what is the kind of object it is, and after that it is being converted into text, and after that it is sent to the server, and it is converted into audio. So as an outcome, we have tested the whole thing, and we will just present it as a demo, as a video script over here. So on this, we are saying like the trigger is the phone button. The phone button is a trigger where you just hold the button and you just release it, and the process automatically starts within a fraction of seconds. so that the image is first captured and just gone into the server and within the seconds. On the phone screen as well as in the down part of the video, you can see what is the process exactly happening over the process, like how it is being captured and how it is being automated. Nothing has been done through the hands or anything. It's just been fully automated. On a conclusion, we just want to say that the work we have developed is just with a collaboration with a smartphone. It's not fully automated. Like it cannot just survive without a smartphone. So on this basis, like since it's a base model, we have just collaborated with the smartphones, and we have done it in a very low cost and a lightweight, and it has a system which has ability to get through the images in a very high quality so that it can get the images on a proper manner and it can easily recognize. And this can be implemented on the global basis since it uses a worldwide, Google uses a worldwide things. So it has already has every data, like every languages, it can be trained. So like even if you implement in any other country having a different language, it can, if you trigger the language will be detected since they are having the server capability of that thing. And the major disadvantage we found in the concluding of this system is it is not able to detect very complex objects such as human faces and objects which are having a similar shape. Like if you are having a cube as well as another thing which is similar to a cuboid, so it will be like having a confusion like exactly what is this. So this can be overcome by having a special trained model so that it will be getting into the future work. The future work we are working on it now is we are using a microcomputer which is a Raspberry Pi Zero, which is a microcomputer. We can just train that. Even we can use training as well as the Google Lens. We can combine the both, so it can be like more effective, and it will be like more of a thing. You will be having a computer nearby your head, so that it will be like processing the whole thing. Even the things which Google Lens is failing to do, the things we can add it to the microcomputer, so that we can program it as the thing. And we also have an idea of making it as a 360-degree camera, so that they will be having a thing like they will be directed through the system, so that if they want to move on a forward or a backward, if they have any obstacles or anything like a dip or anything they have in front of or a side, they can be notified, so that they can be on a smooth way of over the lanes or any path we are going. And we have referred the works which are done by many people, many researchers. So the major researchers which we have referred is about who are using about the systems which are for image recognition. And
sorry for interruption, but the time is over. Can you please wrap it up?
Yeah, sure. That's it. It's going to finish. So these are the papers we have referred. And yeah, thank you.
Sir, any questions?
Yeah, thank you, Jay Sridhar.
Yeah, thanks, sir.
No question from my side, please.
Okay, thank you, Jay Sridhar. We'll move to the next author.
Thank you, sir.
So the next author is Prajwal Valchale, and his paper title is Speech Emotion Recognition Using Machine Learning. Prajwal, can you hear me?
Hello, everyone. Yeah. Let me share my screen. It's visible?
Yes, it's visible. You've got 8 minutes.
Yeah. Hello, everyone. Today I am here to present our research of speech emotion recognition using machine learning. My name is Prajwal Valchale, and my co-researchers are Rohini Mergu, Rupali Shetty, Yash Bagade, and Shruti Embi. My today's agenda is introduction, purpose, dataset, methodology, MFC, CNN, results. First, introduction. Emotion plays a vital role in our interpersonal relationships, whether it is with human beings or with these machines. Analyzing and understanding our emotion helps us to make logical and relational decisions. Human language provides a wealth of information about an individual's mental and emotional state. Speech also gives us information about the speaker's age, gender, locality, emotions, etc. There are enough applications to detect human emotions when interacting with robotics, voice monitoring, synchronous and virtual learning, audio surveillance, web-based learning, clinical studies, entertainment, banking, call centers, computer games. This is purpose of our the purpose of speech emotional recognition is to analyze the identify the emotional content or affective state conveyed in the person's speech. The main objectives of speech emotional recognition includes emotional understanding, human computer interaction, emotion analysis for research, voice assistant and virtual agents, healthcare and mental health, customer experience and sentiment analysis. The ultimate goal of speech emotional recognition is to enable machine to interact and respond the human emotions effectively and creating more natural and emotionally intelligent human computer interactions. We have used 4 data sets for our research: survey audio visual expressed emotion, Ryerson audio visual database of emotional speech and sound, Toronto emotional speech set, and crowd-sourced emotional multimodal actors datasets. The datasets are collectively around 12,000 samples are collected from these 4 datasets. We have sampled this data within 2.5 seconds, and we have divided these datasets like around 9,000 samples for the training and 3,000 samples for the validations. It is divided into 7 emotions like happiness, anger, calm, fear, sadness, surprise, disgust, and neutral. These 7 emotions further divided into 14 gender separated emotions. This is my methodology. First, we have converted to 4 data sets into a master data set. Then it is provided to a feature extraction block, which is from the feature extraction block we get MFCC feature, and after that MFCC feature will get converted into the 2D matrix, and it is provided to the neural network. Our neural network is means the input of the neural network is represented by the 2D matrix. The neural network consists of 5 convolutional blocks, which encompasses a convolutional layer and combination layer. After that, it is like classified into the 7 emotions: happy, sad, neutral, angry, surprise, disgust, and calm. The MFCC is a male frequency capstone coefficient, which is commonly used to speech and audio signal processing. It is provided as a compact representation of the spectral characteristics of audio signals, which is represented on the right side. You can see that male spectrogram of the male. It is a output of the MFCC, means it is a output of the male sample, male voice sample, and we use this. We converted this image into the two-dimensional array and provided to the CNN models. CNN is the convolutional neural network. It is highly effective in tasks like image recognition, object detection, image classification. These characteristics have the convolutional layers, pooling layers, non-linear activation functions, fully connected layers. So I will directly come to the results. Here we have trained 2 models like 1D CNN and 2D CNN. 1D CNN is the one directional convolutional network, and 2D CNN is 2-directional convolutional network. Our model basically recognizes 2 things: gender recognition and emotion recognition with the emotion recognition with gender. First of all, our 1D CNN results are quite low. It is 43% of accuracy, and gender recognition is 80%. Gender recognition with emotion is 81% accuracy. And here drastically decrease the emotion recognition, and without gender is 48%. In our 2D CNN model, we can see that accuracy is quite improved. It is overall 67.58%, and gender recognition is 98%. Where you can classify you can recognize the voice of the genders. It can classify it male or female voice. And without gender recognition means without gender recognizing the emotion, it is 65% accuracy. We can see here the 1D CNN test and train graph. And on the right side, there is a confusion matrix of the 1D CNN results. Here are the gender recognition accuracy matrix. And on the right side, there will be the 1D CNN emotion accuracy matrix. Here are our 2D CNN results. We can see here that the train and test graph is quietly improved from the CNN 1D CNN model. The confusion matrix which consists of the emotions. Here we can see that female angry. Here we can see that the emotions is classified into the genders, and here are the our 2D CNN gender accuracy, which is 98%. You can say that we provided the we provided the sample to the model, and it detects the female sample is 706. Out of which wrongly detected 27 samples only. And here are the emotions accuracy confusion matrix. Here are the
Sorry for interruption. It's 7 minutes. Can you please conclude as soon as possible?
Yeah, I'm on last slide. Yeah, so here are the my actual results. The accuracy we can see here, the 43%, and accuracy of 2D CNN result is 67%. Here we compared compared the previous researches and our research. The all research here we can see 78% accuracy, but it is for the only 4 emotions. But we used 7 emotions. We take the 7 emotions and we able to achieve that 67.58% of accuracy using 2D CNN model. The conclusion: the purpose system examines the accuracy of the performance distribution of speech emotion recognition using the methods of 1D CNN and 2D CNN. For the data sets, we have used 4 data sets. It is showing the high accuracy. Means it is maximum accuracy we able to achieve 67.58%. Thank you. That's all from my side.
Thank you, Prajwal sir. Paras sir, any questions?
Thank you, Prajwal. There is one quick question. Can you come to the result slide? First slide for the result. Above that.
Yeah.
Yes. Okay. So in this, we can see that the 1D CNN and 2D CNN, there are 2 models. And based on that, we can say the 1D CNN accuracy is higher in case of gender recognition. Sorry, 2D CNN is having the higher accuracy of the gender recognition, while I'm sorry, I am some confused. Okay. Great. So why we use the, have you ever tried this with the less emotions, like 4 emotions, as you said that in the history also it is per night. So if we can get the better results from the 1D CNN model, because 1D CNN is having the less results than cloud.
So 1D CNN model is means there is a kernel moves on that image. Means it is a better recognition capability of 1D CNN is quite less compared to 2D CNN, because 2D CNN is the advanced version of 1D CNN.
Right.
Yeah, I tried I am able to achieve only the 43% of accuracy with 1D CNN, and if I increase the convolutional layers in the model, the accuracy drops drastically.
So will we get the same accuracy, same ratio of accuracy with the 4 emissions also in both cases?
Pardon me, sir. Can you repeat your question?
Can we get the same level of accuracy, same ratio of accuracy with the 1D CNN and 2D CNN with 4 emotions only?
Yeah, it is possible to get that accuracy. But in the previous researches, they already used that 4 emotions. So we tried the higher emotions. We are taking the higher emotions for that.
That is what I am saying. Have you tried with the 4 emotions on 2D CNN?
No, sir. We just referred the previous researches. We have not tried actually.
Because 1D CNN is always the lower version, and as you are saying that this is the extended version, so it may have with a higher number of emotions. This model is good, but lower number of emotions, it may take 1D CNN can give the better result or can say equivalent.
Yeah, sir. Yeah, in our here we can compare is we have comparison with the emotions. Here we can see that 1D CNN model used in the 2015 with the Andrew mass, but they have not classified that emotion, how many emotions they are going to have. But there are means impressive accuracy is achieved by them.
Yeah, but my suggestion is just you should check with lesser emotions like 3-4 emotions with 2D also. So it will give the perfect how it is extended with the more emotions, or at the less emotion that both models are almost same. So if you want to do with the less emotion, then you can go with the 1D CNN, and if you are having the more emotions to write, then you can move with the 2D CNN. That is what I want to do.
Yeah, okay, sir. I will note that your solution.
Yeah,
thank you.
please. Thank you, Prajwal. Thank you very much.
Thank you, sir.
Okay, thank you, Prajwal sir. We'll move to the last author for this session now. And we have Sharda M. Kori, and a paper title is Web Application for Monitoring Foundry Processes Using IoT. Sharda ma'am, can you hear me?
Yes, sir, I can hear you. Good morning to one and all. So today I'm going to present my work, which is done on monitoring the foundry processes using IoT technology. So I'll share my screen.
Yes, ma'am.
I hope the screen is visible, sir.
Yes, ma'am, it's visible. You have got 8 minutes. You may start.
Okay, so this is our title of the paper, Web Application using Foundry for Monitoring Foundry Processes using IoT. My co-authors are Professor Mahesh Kori from Mechanical Engineering, Akshata Kori from EC Department, and Parth from CS Department. So first of all, I would like to tell that this paper has been done with the help of people from so many other engineering domains, because it is an interdisciplinary project where we are trying to monitor the processes in the foundry with the help of the technologies like IoT. So to move forward, I'll be quickly going through the table of contents. Here I have mentioned what is the problem statement and how exactly we have come across the literature survey by visiting the various industries that are situated in Belgavi. Then after that, we have come to the conclusion, what are the requirements, how we can make it automated with the help of the IoT technology. Then comes the final design details and prototype, implementation details, and finally the future scope. So this is about the table of contents. To move forward, I'll just quickly go through the problem statements once again. That is to design and develop a web application for monitoring the foundry processes. So about the industry. So Belgavi, those who know about Belgavi, it is a hub for foundry industries. So we have chosen one industry which is situated in Udembag, that is JPF Metacast, and they requested us to automate the processes with the help of the IoT technology. So that was our project which we were doing for JPF Metacast. About the industry, it is basically providing the tight casting weighing, pressure tight cast weighing of various grades to Indian as well as international clients in machined as well as unmachined condition. So with respect to this project, it is like a real life project. Here we try to implement the IoT technology for automating the process monitoring that was happening in the foundry industry. So that was done with the help of the very simple web application, but however, it was very crucial for that industry. So though I have mentioned few points in literature survey, it is not about this. It is basically we visited the industries and we asked them the requirement, how best we can reach their queries and how we can make best use of the technology to automate the processes, which is very crucial for the foundry industries. So, however, right now, everything is manual, which requires more documentation and more manpower. So, in order to keep track of the documentation, raw materials arrives and whether that part has been completed or not, whether the good has been dispatched or not, all those things, it was taken care by the manpower only. So, there is no automation at all existing in this JPF Metacast, or otherwise in other foundries also it is not existing. So, we try to address that issue. So for that reason, the requirement was in terms of their requirement, we call it as a functional requirement, where they were asking for a login page where the company admin has to access the portal, and then the other details will be provided. For this, I would like to share the screen. I'll just show the demonstration of that. So this is how our login page looks like. Here it will show the welcome message, JPF Metacast. Here the admin has the provision to add the employee details, customer details, and we have added two parameters here. One is monitoring the temperature, that is furnace temperature, which will be very high, around 800 degrees centigrade and all. So for that reason, we have used temperature monitoring, and also monitoring the manufacturing process stage by stage. So that I'm going to show now. So initially, when we proceed with this, this customer details and employee details, only the admin has the provision to add. Then in order to monitor the temperature, how exactly we can go through, just I will show that. Sorry for the inconvenience. I'm switching between this. I hope it is visible. I hope it is visible to all.
Yes, ma'am.
Okay. So this is how we are trying to make the web page monitoring the industrial process. Here you can see about the industry, and then which are the services that are provided by that industry, then live tracking of the process which they have initiated, and the login page for the admin. So the login page for the admin includes the email and the password. Then after the successful login, then they will be moving to the next part, that is this part I was showing as a demonstration, where the admin will be having the provision to add the employee details, customer details, and monitoring the temperature and the manufacturing process. Here we have taken three companies' name as a employee details: Ashoka Irons, JSC Steels, and AKS Pipes. So here they are the clients of this JPF Metacast, and the customer details we have not implemented because that will be taken care by the industry itself. Then I'll be switching back to my demonstration. So I hope it is visible. Sir, is that visible?
Yes.
Yes, ma'am.
Okay. So now when I click on monitor temperature, then we can say for every 5 minutes, the furnace temperature will be updated over here. So in terms of degree centigrade, and here the code for the furnace will be mentioned, because in the foundry, they will be using a number of furnaces depending on the requirement. So we have given the code for the furnace, and the parameters are time and the temperature. For every 5 minutes, we are going to read the temperature. So this is about monitoring the temperature, because the temperature is too high and there is no human involvement required. For that reason, we have chosen this. And for temperature monitoring, we have chosen RTD as the sensor. So RTD, it is highly precise, and the temperature range is around -20 to 850 degrees centigrade. Hence, we have chosen this. Then after that, we have added one more parameter, that is monitoring the manufacturing process. This is very important. We can see here, as I already told, these are the clients of JPF Metacast. Here we have categorized the entire process of casting into different sections, that is pattern, molding, melting and puring, fitting, inspection, and finally the dispatch. So Here, the green bubble indicates that it is successfully dispatched to the particular client. If we come to this company AKS Pipes, you can see the gray bubbles indicating that that process is still in the molding stage. So yet to be melted, curing, fitting, and finally dispatched. So this is what we have done for the JPF Metacast. And apart from that, I would like to show one more objective of this. That is.
Sorry to interrupt, ma'am. It's time. Can you please?
Yes, sir. Yes, sir. Yes, sir. Anyways, was an additional thing. Okay. Yes, sir. I can just conclude.
Yes, you may conclude, ma'am.
I can conclude. Okay. So this is our implementation details. We have included Arduino Uno just to monitor the temperature with the help of RTD sensor, and we have used some driver circuits so that we can get the data in the appropriate format. And then we have interfaced it with a LCD so that the customer, the employee can directly read the temperature of the furnace without going directly to the furnace. So this is what we have done, and future plan is like we want to implement it for the other industries also. Right now it is implemented in JPF Metacast Belgaumi Udyambag. Thank you. Thank you for the opportunity. Is there any questions?
Thank you, Sana. It was good paper, in fact. And at this point, I do not have any question. So, please, Somnath, please proceed.
Okay, thank you, Paras sir, and thank you, Sharda ma'am. And I think with this, we come to the end of this session. All our 10 authors are done. So I'll just take a few minutes of yours for the closing remarks. So I sincerely thank all our authors for their excellent presentation in this session and all our participants for being a part of this international conference. I hope that this session was informative enough. We, on behalf of the whole team, thank you for the support during the 8th version and the previous 7 versions of this conference. We will be happy to have you in the next 9th version in 2024 as well. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer, and the publication will be live within 6 months. So please kindly cooperate with the team of ICT4SD 2023. I also thank our session chair, Dr. Paras Kothari, for chairing this session. And for him, we have a token of appreciation. And this is from the team of ICT4SD, sir, for you. And would you like to say something, sir, before we conclude with this session?
Thank you, Shamas. And I must say that it is a very good practice to have some diversified papers in one session. Maybe for me, it was like very difficult to judge, or can say very difficult to analyze the paper related with the agriculture, paper related, because those are not my subject. But I enjoyed all the papers. All papers were very having very insightful information, and definitely by giving some of the ideas or some of the suggestions, I must think researcher will get some more exposure to those fields and some more insightful information for their further research. I wish all researchers best of research work for their future endeavors. And thank you so much. Thank you to Team ICT4SD for giving me this opportunity, and convey my regards to everyone in the team. Thank you.
Thank you so much, sir. Now I request, please, everyone, can you turn on their cameras for a quick snapshot? All the authors, please switch on your cameras. We'll wait for 15 seconds more, and then I'll click our snapshot.
So much I would love to have this photograph also along with my certificate on my mail. Thank you.
Sure, sir. I'll tell the team to forward it to you.
Thank you.
Sharda.
Sir, actually, my system is not connected to camera.
No problem.
Using desktop.
No problem, ma'am. Ishita Sharma, if you may, please.
All right.
Okay. I think let me click just.
There is problem in my camera. I cannot.
Okay, no problem. I think we have waited enough, so let me click a snapshot. So please, everybody smile.
Okay, sir.
Thank you so much, all the authors, and thank you, Paras sir. I clicked the snapshot. May you all have a great year ahead. wish to see you on the next year also. Thank you so much.
Thank you so much. Thank you, everyone.
Thank you, sir.